In Math 30-1, we're going to continue today with topic 2.2, the square root of a function. That's found on page 78 of our texts. By a function, we're talking about f at x, and by the square root of a function, we're talking about the square root of f at x. In example 1, compare the graphs of a linear function and the square root of the function. In A, we're going to be given that the function f at x is 3 minus 2x. We want to graph the function and the square root of the function on the same axes. So the first thing we're going to do is develop a set of points. If x, for instance, is negative 2, 3 minus negative 2 times negative 2 would be positive 7. That means the square root of 3 minus 2x will be root 7. If I went to negative 1, 3 minus 2 times negative 1 would be 5. So the square root would be root 5. 0 would give me 3 and root 3. And for 1, when x is 1, 3 minus 2 times 1 is just 1, and the root of 1 is 1. For 2, we're going to find that we're going to get a value of our function of negative 1, and for our square root of negative 1, that of course is undefined. So we seem to have gotten smaller and smaller and smaller, and now we get passed into the negative values. Let's go back a half a point and see if we can figure this out. If x was 1.5, that means my function would be 0, and my square root of that function would also be 0. Now we're going to plot some points. If I make a coordinate plane, and I first of all draw in y is 3 minus 2x, I can plot the points. X is 0, y is 3, and I can also plot the point when x is 1, y is 1, and when x is 1.5, y is 0, and draw a line through it. Next, I'm going to plot the point when x is negative 2, y is root 7. When x is negative 1, y is root 5. When x is 0, y is root 3. 1, 1 goes there, and 1.50 also goes there. So there's 2 points that are going to be the same in both graphs. Those are going to be invariant points, and when I draw the curve in, that's what it's going to look like. The red curve is going to be 3 minus 2x, the square root of 3 minus 2x, and the line is 3 minus 2x. And there you have your invariant points. For f of x, the domain is going to be x can be any real number because it's a straight line, and of course our range is going to be y is any real number. For the square root of f at x, our domain is going to be x has to be less than 1.5 or equal to 1.5, and our range is y has got to be greater than or equal to 0. In example 2, we're asked to compare the domain and ranges of the functions in each pair. For A, y is 2 minus 0.5x squared, so this is going to be a quadratic function, and y is the square root of 2 minus 0.5x squared. And for B, y is equal to x squared plus 5, and y is equal to the square root of x squared plus 5. Now you can analyze these functions graphically, or you can analyze some key points. We're going to do a combination of these. First of all, there's the graph of y equals 2 minus 0.5x squared, and in red is the graph of y is equal to 2 minus 0.5x squared. All I did was plug these into my calculator, find the points, and graph them on paper. For y is equal to 2 minus 0.5x squared, you'll notice that my domain, x, can be any real number because it's a parabola, and for my range, y has got to be less than or equal to positive 2 because that's the maximum point and it goes down forever from there. For my x-intercepts, they're going to be at 2, 0, and negative 2, 0. My y-intercept, of course, is at 0, 2. The maximum of this function is 2, and there is going to be no minimum. For my square root function, 2 minus 0.5x squared, my domain is x has to be everywhere from negative 2 to positive 2. For my range, y has to be anywhere between 0 and root 2. And my x is going to have a minimum at negative 2, 0. And, the x-intercept is at negative 2, 0. And at positive 2, 0. My y-intercept is 0, root 2. It's going to have a maximum at root 2 and a minimum at 0. For b, y is equal to x squared plus 5 and the square root of x squared plus 5, you're going to complete as your turn. In our third and last example, we're going to graph the square root of a function from the graph of the function. Alright, in our first one, well, for both of these, what I want you to notice is that there's going to be some certain steps to follow. We're going to locate the invariant points, step 1, and when graphing the square root of a function, the invariant points are going to occur when y is equal to 0 and when y is equal to 1. Those are going to be the red dots that are showing up on our graphs right now. Next, step 2, we're going to draw a smooth curve between the invariant points, between 0 and 1, and we're going to draw it above the graphs. So as you can see, I drew it above the graph on the line and above the graph on the parabola. Step 3 is going to be locate other key points where the values will be greater than 1. So what we're going to do here, in the first graph, you'll notice that when x is 0, y is 4. Well, if we're working with the square roots, I can now say that the square root of 4 is going to be 2. So on that graph, you'll notice that that line has got to go through the point when x is 0, y is 2. Now on the graph on the right, I'm going to look at, well, when y is 9, the square root of 9 is 3, so I'm going to look up there and say when up at the top it's 9, down there it's got to be 3. So on both of these arms, I can draw the point 0, 3 underneath 0, 9. Then I can draw my line through, and I've got a pretty good idea of what this graph is going to look like. You can always check by using your calculator to make sure you're drawing it correctly. Your assignment is to do page 86, 2 to 11, 13, and 17.